So right now we're going to work on complex numbers, section 1.4, different things with imaginary numbers. So number 1, evaluate the following square root expression. So we can kind of think of this as the square root of -1 times the square root of 64. Okay, the square root of -1 is I, the square root of 64 is 8. Okay, so I8, this is, of course, is multiplication. We would really write this as 8i. So our answer for the first one is 8i. For number 2, we have a negative, and then I can think of this -121 as the square root of -1 and the square root of 121. I'm going to keep this negative sign out front alone. Just kind of ignore it and carry it down. So the square root of -1 again is I. The square root of 121 is 11. So I have negative I times 11. So we would write this as -11i. Okay. For the next one, so we can kind of again break this up as the square root of -1 times the square root of 72x to the third. Okay, and I know that this first part is going to be an I. For the second part, square root of 72, I want to think about perfect squares that go into 72. So 1, 4, 9, 16, 25, 36, 49. And I want to find the biggest perfect square that goes into 72. So that one would be 36. So I'm going to rewrite this as 36 times 2, and then I've got 3 x's. That's x to the third. So the square root of 36 is 6. All right. I've got a group of 2 x's here, so one's going to come out of the square root symbol, one's going to stay inside, and this one kind of goes away when I break that out. So I've got an x on the outside. Remaining on the inside, I have this 2 and this x. Okay, so my answer is I times 6x square root of 2x. And we can write that as 6xi square root of 2x. Number 4, simplify the following expression. So this is basically a combining like terms problem. But to get started, we're just going to distribute this minus sign to everything in the set of parentheses here. So that'll be 12 minus 18i minus 6 plus 16i. So I'm going to have 12 minus 6, that's 6. And then I'm going to have negative 18i plus 16i, so that's minus 2i. Number 5, simplify. When I look at this problem, I notice that these two things right here are conjugates, meaning they have the same numbers, their signs are just different. So when this happens, the middle two terms should cancel. So let's make sure that that does happen. 2 times 2 is 4, plus 18i, minus 18i, minus 81i squared. So here I get a cancel, which is what we anticipated to happen. So I'm left with 4 minus 81i squared. Now remember, I squared is -1. So I'm going to change that I squared and think about it as -1. And -1 times -81 will become a positive 81. So then my final answer is 85. In number 6, these two things are not conjugates, so our middle terms will not cancel. So let's just start multiplying. We have 15 plus 3i minus 10i minus 2i squared. I'm going to combine my middle terms, so that's 15 minus 7i. I'm going to think of this guy as a -1. All right, -1 times -2 will become a +2. Then I'm going to combine 15 and 2. So this is 17 minus 7i. All right, this squaring means I write this out by itself, being multiplied by itself. And now we multiply as normal. These are not conjugates, so our middle terms will not cancel. This becomes plus 4i squared, negative times negative. I'm going to combine these middle terms. Again, those do not cancel. That becomes negative 24i. I squared is negative 1. So I'm going to think about this as 4 times negative 1, which is a minus 4. I need to combine these two. So 36 minus 4 is 32 minus 24i. All right, now we're getting to some of the good stuff here. Simplify the following expression. So since I is a square root, that is not allowed in a denominator, and that's what's happening here. I have a 5i down there. So in order to get that to go away, we're going to multiply by the conjugate. The conjugate on this example is 3 minus 5i. I keep the numbers the same, and I just change that sign in the middle. And I multiply top and bottom by that conjugate. So 3 minus 5i, 3 minus 5i. Oops. All right, so in the numerator, I'm going to distribute the 3. 34 times 3 is 102, minus 34 times 5 is 170, and that's an I, over. Now, when we multiply conjugates, the middle two terms will cancel, so I'm going to shortcut this a little bit, and I'm going to do 3 times 3, and 5i times negative 5i, which is a negative 25i squared. Okay. I'm going to simplify this denominator. Not a whole lot I can do with the numerator right now, so I'm just going to rewrite that. But remember, I squared is negative 1. So negative 25 times negative 1, this will become 9 plus 25, which is 34. Whoopsies. Okay, now I'm looking at the fraction as a whole and seeing if I can just reduce the numbers here. 102 divided by 34 works. 170 divided by 34 also works. So 102 divided by 34 is 3. 170 divided by 34 is 5. So this becomes 3 minus 5i. That happens to be the conjugate in this example. That's just a coincidence. Okay, that is not going to happen every time. Number 9, we need to do the same thing, multiply by the conjugate. So the conjugate is 5 minus I here. All right, in the numerator, we're going to have to multiply this out. So we have 5 times 4, 4 times negative I, 5 times I, and I times negative I, which is negative I squared. In the denominator, we're going to do 5 times 5, and I times negative I, which is negative I squared. I'm going to skip the middle 2 in the denominator since that's the conjugate, and those terms will cancel. So in the numerator, let's clean this up. So I squared becomes negative 1. Negative 1 becomes plus 1. So I'm going to add that to 20. So I have 21 there. Then I have negative 4i plus 5i, so that'll be a plus 1i. In the denominator, I have 25 minus negative 1. So again, this will become a plus 1 to 25, and that'll be 26. I can't reduce that anyway, so there's our answer. 21 plus I over 26. In Hawks, you might have to write that as 21 over 26 plus I over 26, and write it as two fractions.